Welcome to the project Programming a God. Today we will be solving the toys problem from Google Kickstart Round E 2020. Let's look at its problem statement first. This is the problem statement. There is a small child named Axel. He has n number of toys numbered from 1 to n. Each toy has two properties, namely enjoyment E and remembrance I. Enjoyment is the time Axel can play with a toy before getting bored with it. Remembrance is the time Axel takes to forget a toy. The toys are arranged in a circle. Axel starts to play with the toy having the smallest number and plays with the toy having the largest number at the last. After playing with the toy having largest number, he starts again from the toy with smallest number. If Axel reaches some toy that he has not forgotten about, then he starts to cry. A toy is forgotten if remembrance amount of time has passed before playing with the toy again. We have to determine the maximum amount of time Axel can play before he starts to cry by removing minimum number of toys. So our output should be two things: minimum number of toys that are removed and the maximum time that Axel will play for. If Axel can play for indefinite amount of time, then return indefinitely. Note that initially Axel has not played with any of the toys and he should not be left with 0 toys. The input is simple. For each test case we have number of toys n and the value of enjoyment and remembrance for each toy. The constraints are as shown. Consider this example. We have 3 toys with the following enjoyment and remembrance values. This is the circular arrangement. First Axel starts to play with toy number 1, then he plays with toy number 2 and then toy number 3. Since now he has played for a total of 5 plus 4 plus 6, that is 15 minutes. Now he starts again with toy 1. It has remembrance value of 5 and more than 5 minutes have passed since Axel last played with it. So he can play with it and our total playtime becomes 15 plus 5, that is 20. Now he goes to toy number 2, but toy 2 has remembrance value of 15 until now only 6 plus 5, that is 11 minutes have passed since he last played with it. So he will start crying. Now consider this. We remove toy number 2, then our structure becomes like this. First he plays with toy 1, then 3, then again with 1, then 3, and so on. This structure will go for indefinite time. So this is our answer. So we print 1 and indefinitely as answer. This problem needs some thinking. Initially all toys are untouched. So in round 1 Axel can play with all of them. We will use 3 vectors. Vector enjoy to store the value of enjoyment of each toy. Vector remember to store the value of remembrance of each toy. Vector S to store the added value of enjoyment plus remembrance of each toy. We will also use a variable sum which will keep the total of all enjoyment values. So we loop from 1 to n toys and keep adding the values to the vectors and also add the value of enjoyment to a variable sum. Round 1 is over. Now, Axel will only return to a toy after playing with all the other toys. So the time it takes to return to a toy I will be sum minus the enjoyment of the toy he is returning to. Now Axel has returned to a toy I. So we need to decide if he will play with it again or not. He will play if the time it took to return, that is sum minus enjoyment of I, is greater or equal to the remembrance of toy I. This can be rearranged as sum should be greater than or equal to enjoyment of I plus remembrance of I. So in round 2 whenever a toy will violate this condition, then Axel will start crying. So to get our answer we need to simulate round 2. To solve this we will be using a priority queue. A priority queue is a queue in which the maximum value is always at the top. From round 1 we have value of sum and our 3 vectors. Now we will use 4 more variables. Current time variable will keep track of the total time Axel has played till now. Maximum time variable will keep track of the maximum value of current time. Count variable will keep track of the number of toys removed. Removed variable will keep track of the number of toys that were removed when the current time was maximum. Let's start round 2. At the starting of round 2 the value of current time is equal to sum. We currently have an empty priority queue. We will now loop from 1 to n toys. Every time we will add the toy to the priority queue in the form of a pair of s of I, that is the sum of enjoyment and remembrance of toy I and its index. We will also add this toy's enjoyment time to current time. Now we will check if any toy is present in our priority queue which violates our condition. Note that in priority queue the toy with the largest value will be at the top, followed by others in decreasing order. That means that if the top toy meets the condition, then all the other toys in the queue also meet the condition. So let's check the queue till it gets empty or the toys meet our condition. First, get the top toy. Check if the toy meets our condition. Remember that the elements in the queue are a pair of sum of enjoyment and remembrance of the toy and the index of the toy. So top dot first will get us the s of I of the toy, which is the sum of enjoyment and remembrance. We also get the index of this toy using top dot second. If the toy violates the condition, then we need to remove it. First, subtract 2 times enjoyment of the toy from current time. It is multiplied by 2 because the enjoyment was added in current time twice. Once in the first round and second time when the toy was added in the queue. Removing the toy means it never existed. So decrease value of sum by enjoyment of that toy. Increase value of count by 1. Now remove the toy from queue. If the condition is met, then break the loop because the queue is sorted in decreasing order, and if the top element meets the condition, then all the other elements meet the condition. Now comes the last step. After completing the while loop, we need to update our max time. If the current time is greater than max time, then we need to change value of max time to current time and change the value of remove to count. Note that remove tells us the number of toys that were deleted when the current time was maximum. Now finally we get the answer. If the queue is not empty, then it means that Axel can play indefinitely with the toys in the queue, and the number of toys removed to achieve that is count. If the queue is empty, then it means that Axel can play for max time before he starts to cry, and the number of toys that were removed is stored in removed. This problem was very tricky and requires full focus to understand. Next, the C++ code for this problem is provided. Take a good look at it to understand the solution. Please subscribe to support the channel.